Hello Titan Dev Team. Today we are going to be taking a look at creating foliage and other elements that may also tie in well. So I've got a couple of examples here. The first is this thatch roof that I have created, and the second is this nice little green bush. Now, we've already had some good foliage examples added to the project. We've had some of these elements added here. Now, these are really good representations of volume without going into the detail of the actual tree itself. Now, this one you can see here is not quite as good because they're using very flat cards that are kind of intersecting very visibly, whereas this one is using a kind of slightly better approach, and they're getting a slightly better result. But the downside of this is that the way that they're doing it is by really smashing a lot of geometry one on top of the other. And the problem that creates is a thing called overdraw. Now, overdraw is a really big consideration that you need to make with nanite because we get some quite big performance hits whenever we're using a lot of overdraw on to represent our geometry. Now, to some extent, we're not going to be able to solve this 100% because the way that we're going to represent this shape, it just has to have some level of overdraw in it. It's just the way that foliage, kind of has to be represented, almost regardless of the art style that we're going for. But that being said, there are some ways of resolving this while still getting this nice kind of volumetric look. Now, the two main ways of solving it are one, to not use a masked material, because whenever we use masked on nanite, we massively increase the performance hit on that asset. And then the second is basically by reducing the amount of work that our cards are doing by introducing blocking volumes. Now, you'll have probably used these volumes to generate some of these assets, right, from the look of it anyway. But one of the uses of keeping these in is that they can really help with reducing the total number of cards that you need to get that volumetric look while still being a good example. I don't know what I've done there. There we go. Let's go back. Now, this is not needed for everything. We can have areas where we're using, the cards in some areas and not in others to kind of get a good balance. So maybe the outer shape doesn't have the blocking volumes in it, or you're not using it everywhere. But for foliage elements like this, where we are 100% blocking any visibility through this tree, all of these shapes here, we really want to be inserting a blocking shape. The big advantage of that is that we don't need to put any interior geometry into this surface now in order to keep that representation, because we've got that big blocking volume in place. And I've got a good example of, kind of the differences between those two. If we take this, kind of small bush here that's also been made, we can take a look. And if we go to our nanite and our overdraw, you can see the difference between one, cutting out the shape rather than using a mask material, but also because we're not having to add geometry to represent that interior structure, because we don't need to, we're not having to overlap a load of geometry, so we're avoiding creating that massive spike in the middle. So the way that we can go about creating this foliage as a quick example, so I use Blender for it, and I tend to try and keep as much of the original asset as possible when I'm building. So what I will do is I will create my blocking shape, I unwrap it to make sure that I have a good tangent direction as well as my normal. I'll use a normal edit to give it a really kind of nice volumetric feel. Again, if we can match the normals between the interior shape and the cards that we're placing on top of it, then we will get a much cleaner, kind of blend between those cards and the inner shape. I'll then use a particle spawn on top of that surface. So again, I've got one here enabled. I'm just going to go in and hide these other shapes. And as long as we have unwrapped the inner surface, we should be able to get a good directionality to this. So if we make sure we're using hair, tick advanced, and then go to rotation, what we can do is when we check again, I'm just going to get rid of all of these. You can see that these have a nice clear directionality to them, and I can kind of point them in a set direction, and they're going to kind of align quite nicely. So the more directionality that we can get, the better, because generally if we have a good directionality, we can reduce these cards overlapping and intersecting on top of one another. Generally we want to try and avoid intersection as much as possible. Now you can see that these are the cards at the moment. They each have their own normals, and ideally we don't want that. So in order for us to fix that, we need to go in and we need to make those instances real. Now there's way more information that you can put in on the actual particle generation for these cards. But I'll leave you to look into that. Main things that you need to keep in mind are just vertex group for controlling spawning and scale and things like that. And then just making sure that you have access to that rotation value by adding advanced, and then choosing, kind of rendering it as. So I choose object if I'm just doing one. If I need multiple, then you put it into a collection and then tell it to use a random selection on that. And that's the bulk of it. But anyway, for this one, I'm just going to hide these because I don't need to export them. I make the instances real, and then I put them inside a standalone collection. Now, the nice thing about doing this is that each of these assets are still connected to that original instance that I made. So if I go in and I edit this, you can see that we can kind of tweak that asset and we get a really nice look. So if I want to put like a bit of a lip into this, so a little bit of a ridge coming up, I can do that really easily on that surface, and it's going to retain that link to those assets. The other thing that I'm doing as well is because I'm keeping this as a kind of original asset, I've got all of the original subdivs on this as well. So remember, when you're building, subdivisions are incredibly cheap. Nanite can cull these really, really easily. We can go in and reduce them down really easily. And as long as we keep the original asset, it's really easy for us to export original subdivs as well. So I can go in, I can remove the subdivisions from this and propagate that across to these, kind of assets here. And this is going to give me my low poly that I can now use both, kind of on the mobile version or the Switch version of this game. But I can still retain all of that nice high poly information. And what's also nice is that because when we're modeling, if we again go in and we have a look at this surface with our subdiv view, you can kind of see that we have, we never exceed the outer shape of this subdivision, because that's generally how subdivisions work. So what that means is that we can very, very easily create a mask that we can then apply to that lower subdivision version, and then set that onto the material that isn't using nanite. So we can very easily apply a nanite fallback or a non-nanite fallback for that geometry. So this is a really nice way of working, where you kind of retain that original data. It's very easy to edit. Very easy to go in and make those shapes and kind of tweak them and edit them. So I can go in, I can add extra information like that. It's really easy to do, and we can see that change on the actual, the propagated element. So once I've done that, I just need to make sure that my normals are all aligned together. Again, you can just use a radial on that or a directional, depending on how you're building it. I use directional for the thatch, but using radial on this one is quite nice. Again, when you're working, with a single asset like this, we can actually fake the normal very easily just by getting the object position and then setting the normals manually in the material. But if you are creating an asset that has like multiple tree elements, then you'll want to have an individual normal for each of these, so that you still get that nice volume. And again, all we're trying to do here is get a good representation of that volume. And then once you're happy with it, you can export them out. So again, select all of the ones that you want to export, export them out as FBX, import them into the engine. And then the main thing you need to make sure when you import them in is that you are ticking combine meshes. And what that will do is it will import all of these in as a single asset rather than a, kind of 100, 200 standalone individual elements. So that's just something to keep in mind when you're bringing it in. Now, if you want to get individual per leaf, in quotes, movement, there's a really nice, easy way of getting that assignment without having to go through, kind of Houdini or anything like that to get that data. Now, there's a bunch of plugins in Blender that will do this, so you can download those as well. But an easy way to do that inside Unreal is by going to our attributes, generating polygroups, and then telling it to do it from connected triangles. And what that will do is it will select each of these individual mesh elements, and it will assign them a polygroup. Now, that's not going to do anything for the actual mesh, but what it does mean is that we can now go into our bake options, bake vertex colors, and then on our RGBA setting, assign that to polygroup ID. And what that's going to do is assign a unique vertex color to each of these individual sets. And that's going to make it much easier for us in the material editor to go in and assign some kind of per leaf variation to the surface. Again, there's a demo of this inside Titan. You can just go in, open up that foliage example, and I've kind of built in a way of kind of like extracting some of that vertex color data and then using it to create kind of some per wind variation, and also you can do it to create some per color variation as well. Now, when you're texturing these, you want to try and put in as little variation as possible that isn't kind of globally affecting the surface. So as an example of this, I've put in a gradient because again, this is really nice because it's across the entire surface. So it's going to be much less likely to create any harsh intersecting shapes on that surface. If you start to put in very unique texture information on that, it's going to become quite noticeable very quickly where it intersects with the surface and where it meets with the inner shape and things like that. So try to create as little variation as possible that's not being kind of globally affected. So again, kind of a world space noise would work quite well. Gradients work quite well. It's one of the reasons why I will often, if we look at the UV on this surface, I can create a nice gradient from here to here. And that will generally work quite well as long as my inner shape is kind of at the bottom of that gradient. And then it can kind of work its way out. So there's a few different ways of creating that nice kind of variation without, kind of losing that nice volume that you're creating. And again, it's very easy to lose that volume. Again, if we look at this, you can see where we get those harsh lines and intersections on the normals that aren't working correctly. We get very visible, kind of like breaking of that surface. And again, where we're trying to create that big volume, we want to try and fake that as much as possible. One last thing on the normals front is that by default, Unreal will try and do some recalculation on it because it's not expecting this kind of surface to be imported in. So when you import the asset, just make sure you type in, spell it correctly, normal, and then just tell it to not recompute normals and also to not compute weighted normals, which it is going to try and do on that surface. So you can kind of see the difference there a little bit that it's created. And what that will do is it will basically just mean that it will always use the source normals that you've imported in from Blender, which has those nice kind of aligned normals, rather than trying to calculate them on its own, which is almost certainly going to end up creating a kind of volumetric look on that shape. So that's the kind of main thing you need to do with normals. Then just make sure that you're using the two-sided foliage shading model on that asset. Make sure your blend mode is set to opaque so that you're not paying for the cost of masked. And then you can kind of build whatever kind of foliage movement you want on top of that. Again, I've got an example of this inside here where I've made a Gerstner wave layered function. So again, this is kind of using multiple Gerstner waves to create foliage movement. You'll get a rotation axis on the RGB channels and a strength axis on the alpha channels, so you can kind of mix and match those. I've done a small rotational example, which is this one here, and then a simple kind of just linear offset on the actual leaves themselves there. So that's the main elements that you need in order to create foliage. Just looking at a few of the examples again, so we've got kind of the big comparison. Again, let's just get back that original bush that we want. Make sure that we're giving it a good representation. We got that. There we go. This one here. Let's just scale that up as well. No, that's not the same one. There it is. So we can just see, if we go to our nanite view and our overdraw, kind of the differences between those two surfaces. So where we're not having to add geometry to represent that interior surface, we end up with a much better level of overdraw overall. Same with all of these. So again, you can kind of see the differences here. So that's the main thing we want to try and consider when representing that surface. And then the next thing is just kind of on actual, kind of like aesthetic representation. So these are all good assets. They've been, kind of made reasonably well. I had a bush here as well that seems to have disappeared. It's kind of snuck out the room. Let's see if we can get that back as well. There they are. So these are all good assets. They are, they're absolutely fine. But they do not match the aesthetic. So if we put these two things next to one another, you can see that there's quite a big discrepancy between, kind of these two assets. So what we're going for is to try and make sure that everything is cohesive, right? So all of these, kind of elements here, and there's more of them in the project. I just kind of randomly picked a couple as examples. While they are nicely made assets, they're not good aesthetic matches. So I would say that if you you built these assets, I think they need another go and really try and match kind of that volumetric look and feel for the surfaces. Hope that was helpful, and please do ask questions on the Discord if you need some more guidance.